Hello everyone, this is our data mining final presentation. Here are our 7 team members: 刘宇华、薛佑轩、林志佑、陈元、叶宇焕、孙伟、蔡楚凯. This is our presentation content. We will begin by explaining the detail of the data, including the source in the metadata, as well as how we process the data. Secondly, we will introduce various algorithms, which will be the main part of our presentation. Finally, we will determine the best model based on the algorithm that provide the highest accuracy, and conclude our presentation. Source the metadata. The data set is named 市场良知日行情资料 from the Ministry of Agriculture and the website here. The data set contains 11 variables and 9,999 entries. We choose the target variable highest price to understand the highest price for them for different breeds in different markets and at different times. In the metadata, there are a total of 11 variables comprising 6 nominal, 1 ordinal, and 4 numerical. Market ID serves as the unique identification number for each market. Short name denote the county where the market is located, while name refers to the market's name. Each of these variables can be categorized into 3 distinct parts. Product ID identifies the specific product, in this case, lambs, 羊. Product name specifies the breed of the lamb, and product type name provides additional descriptive information for product name, such as color. Transdate represents the date of each transaction. Since each data entry pertains to a particular lamb, the same transaction date may appear across different rows. The remaining 4 numerical variables offer detailed insight into the specifics of lamb sales transactions for each day. Next, let's discuss data processing. Because the 3 variables express similar information, we have chosen to use only short name. We create a new variable called product, which combines product name and product type name. This variable resembles product ID, but offers additional information. We apply one-hot encoding to both short name and product, resulting in 3 and 11 columns, respectively. For the translate variable, direct label encoding results in ordinal ranking values. To enhance usability, we transform these values into date gaps, measuring days related to the latest date that has been entered in the dataset. This transformation allows for easier calculation and standardization. Our target variable, highest price, is categorized into thirds based on frequency. This approach ensures a balanced distribution, given that data primarily locate in the middle of the range. We believe there were no missing value. However, upon closer inspection, we discover 0 in quantity, average weight, average price, and highest price. Recognizing that zeros in highest price could skew our target variable, we opted to exclude rows of the data containing zeros in these 4 numerical variables.
Next is decision tree. I didn't perform additional distillation because decision tree can handle continuing variables and encoding was done as mentioned earlier. I split the data into 80% training and 20% testing. Here in variable selection, I use 2 methods. T-square choose 10 feature and select one model choose 2 feature. I use select one model because it has better result when modeling. From the chart, only train state and average price show significant feature importance, the rest are low, so I kept only 2 variables. Next, I model with these 2 variables, testing across interval of m equal 2 to 10 and c equal 0.05 to 0.25. The best parameter were c equal 0.05 and m equal 10. Test accuracy is 92.43%. For C, 4.5 with C equal 0.25 and M equal 10, test accuracy of 91.16%. In the 4 variable model testing, the same range Gini slightly outperformed than entropy. For C, 4.5, the best parameter is C equal 0.25 and M equal 7. Test accuracy is 91.76%. Comparing 2 models, partial variables model had higher accuracy. In the final model, there are 53 leaves and the tree size is 18.
I'm going to present association rule in Python. We set up support for 0.02 encounters for 0.5. and there are 596 rules we have. We have 6 variables to find the association rule related to the target variable, sorted from high to low. Because 0.02 and 0.5, we can find all the variables have rules included, so we don't have to resample. First, the highest price which belongs to the low group is associated to the non-standard shift. Time interval 1, which is the longest time interval from today, and the quantity in high group with confidence equal 1. We have lots of rules with the same confidence and lift, so we choose the highest of all rules. Second, the highest price belongs to the medium group is associated to the time interval 3, which is the shortest time interval from today, and average price medium group with confidence equal 0.985591, which is the highest confidence. Third, the highest price belongs to the high group is associated to quantity high group. Median cost weather and average price high group. Next one is association rules in RStudio. Setup support for 0.02 and confidence for 0.5, and there are 583 rules. To choose the rules we want, we sort the confidence from high to low. We can find 3 main rules associated to the target variable. First, the highest price belongs to the high group is associated to quantity high group, median cost weather and average price high group. Second, the highest price belongs to the median group is associated to weather time interval 3, which is the shortest time interval from today, and average price median group with confidence equal 0.98143, which is the highest confidence. Third, the highest price which belongs to the low group is associated to non-standard shift time interval 1, which is the longest time interval from today, and the quantity in high group. With confidence equal 1, we have lots of rules with same confidence and lift, so we choose the highest of all rules.
Next part is SVM analysis. First, data processing. We standardize the columns quantity, average weight, and average price to ensure fair impact contribution in a model. Next, we perform data splitting, allocating 20% for testing and 80% for training. The slide shows the accuracy of SVC and linear under different parameters value. The highest accuracy was achieved when parameter was set to 0.6. SVC exhibit higher than linear, therefore we choose the SVC model with gamma 0.6 as final selection.
Next part is random forest. In a random forest, we discretize the target variable because it was a continuous variable. We divide the data into 3 categories and also record it. In a random forest, we don't need to standardize the data because it is not sensitive to the range and the scale of the data. We split the data into 18% for the training set and 20% for the testing set. I chose 3 parameters in model, an estimator, max depth, and a random state. In the first model, I set them to 306 and our report deadlines respectively, and the accuracy was 19.96%. In the second model, I reduced the number of trees to 250, and the accuracy did not change significantly. In the third model, I set the number of trees back to 300 and increased the depth to 8, resulting in a slight increase in accuracy to 91.62%. In the first model, I reduced both the number of trees and the depth, and the accuracy dropped. We can look at this table and decide to choose model 2 as the best model because the accuracy difference are small, so we prefer the model with lower building cost.
Next is KNN analysis. First is discretization of variable for KNN. Calculating KNN does not involve discretization, as the discretization process converts continuous variables into nominal scale variables. Since KNN is a distance-based algorithm, it is better to use continuous values directly. Second is data encoding. Both label encoder and one-hot encoder are used. Label encoder used to convert translate into numerical form to retain the ordinal nature of states. One-hot encoder used to convert short name and product into numerical form. One-hot encoding allows the model to better distinguish between different categories, avoiding the false ordinal relationships that label encoding might introduce. Third is data standardization, the standardized numerical variables. Standard scalar used to standardize quantity, average weight, and average price. Standardization helps eliminate the influence of feature scales, preventing certain features from dominating distance, calculating due to their larger numerical range. The last is data splitting. The dataset is split with 80% for training and 20% for testing. This is called an output result. We limit k to below 50 to avoid too much computation time. In practical application, k value usually do not need to be set too high. Smaller k value often provide enough good results. Setting too large a k values does not necessarily improve model performance and may result in longer computation times without science fiction benefit. When k is set between 1 and 50, the best k is found to be 40. The accuracy of the test data set is 87.39%. The accuracy of the training data set is 99.83%. Next is the voting and comparison. Based on the best accuracy obtained from different methods, we incorporate their parameters into ensemble models. According to the result, we find voting hard accuracy is 91.05%. Voting soft accuracy is 91%. The last is final comparison. For the accuracy result of SEN, RF, KN, voting soft, and voting hard, it is evident that random forest achieve the highest accuracy and is therefore the best choice.
Okay, I'm going to talk about k-means. Without a target variable, the k-means plot shows a blue line. After adding the target variable, it's turned into an origin line. Combining them is evidence that there are more points on the origin line compared to the blue line. Regarding SSE, it's 33,000 without the target variable and increase to 35,000 with the target variable included. Based on this value, we choose the model with the target variable. In the first clusters, we see a significant proportion of 杂交羊. We see a significant proportion in 淘汰公羊 and a high proportion of the highest price. So we named it 优质羊. In the second cluster, there are no parametrically outstanding variable, but the proportion is highest in 高雄凤山, so we named it 高雄凤山羊. Finally, in the third cluster, we observe the significant proportion of 淘汰公羊 and 规格羊. Then high quantity but low price, so we named it 大众羊. Lastly, the accuracy rate is 0.6982 without the target variable and 0.7162 with the target variable included.
Conclusion. In the beginning, we identified the best decision tree model with partial variables, C equals 0.05, M equals 10, and an accuracy of 92.43%. Midway through, we determined that the best classifier algorithm was the random forest, achieving an accuracy of 91.15%. Finally, we found the best k-means model, which include target variables and had an accuracy of 71.62%. Given the superior performance of the decision tree, we select it as our best predictive model.